Hi everyone, here we go with quadratic functions and analyzing the graph of a quadratic function in general form. So remember last year when you were in Foundations of Math 10, you'd have, there was the slope-intercept form of y equals mx plus b, that's the slope-intercept form, and there was y2 minus y1 equals m times x2 minus x1. That was another, that's the intercept or point slope form of the line. And so these different forms of the equation, they all give us the same line, but they give us different information about that line, and they're useful in different ways. So we're going to start by looking at what's called the general form of the quadratic function, or of the equation of the quadratic function. Okay, so just to recap from the review, a quadratic function has a degree 2, and it can be written as either y equals ax plus bx plus c, or f of x equals ax plus bx plus c, where a, b, and c are real numbers, and a is not 0. All right? The graph of a quadratic function is a shape that's called a parabola. Okay? There are some basic characteristics of the graph of a quadratic that are really important to have a good handle on. The parabola has a maximum point or a maximum point if the parabola opens down. So for example, if our parabola looks like this, there's a point up here, which is the maximum. All right, and then if it opened up, it would the minimum. There'd be a point at the bottom that's the lowest that the value can ever be. The vertex of a parabola is this maximum or minimum point. Okay, so let me draw this over here. Here's another parabola. This one opens up. So right here, that is the vertex right there. Okay, and the maximum or minimum value of a quadratic function is the y-coordinate of the vertex. All right, let's do an example so this maybe makes a bit more sense instead of just being random words that I'm throwing at you. So for the function, the quadratic function y equals x squared minus 6x plus 5, where x is any real number, we're going to complete the table of values for the quadratic function. So the way we do that is we say, usually we do this as an up and down table, but I did it across so that it fit on the page better. So if x is -1, then we go over here and we know that y equals x squared minus 6x plus 5. So y is -1 squared minus 6 times -1 plus 5. -1 squared, remember you're squaring everything in the brackets, so it's -1 times -1, which is +1. And then -6 times -1 is +6. And plus 5. So this is 12. All right, so if x is -1, y is 12. If x is 0, we have 0 squared minus 6 times 0 plus 5, which is just 5. If x is 1, we have 1 squared minus 6 times 1 plus 5 is 1 minus 6 plus 5, which is 0. Okay, I'm not going to finish the rest of the table, but you know, it's usually not worth trying to do this in your head. Just do it on paper. Just write it down. It's so much better to get the right answers, okay? But I'll just fill these in. So this is 12 and 5 and 0, -3, -4, -3, 0, 5, and 12. Now, hopefully you're noticing right away that there's some symmetry here. And that is always parabolas. There's always symmetry. You might not always graph where the symmetry is, but there is always symmetry, as you can see from the sketches that we've done up here. All right, plot the points on the grid provided. So we get -1 and 12 and 0, 5, 1, 0, 2, -3, 3, -4. And then, you know what? I just copy it because it's going to be symmetrical. So I'm sort of shortcutting it there. All right. And then connect the points with a smooth curve and extend the graph. So this is the most challenging part to do, especially on the computer, where I need to go through all the points and sort of, ooh, whoops. Oh, it was too quick. I was thinking I was doing a pretty good job there. Okay, and extend it. So I put those arrows on the ends to say this is going forever and ever and ever. All right. Draw a vertical line representing the axis of symmetry of the graph. So the axis of symmetry is the line where you could fold it in half and it would be the same on both sides. And that would be this very poorly done dotted line. I'm sorry about that. But I want you to notice the thing that's really important about this axis of symmetry is that it always goes through the vertex, okay? Because the vertex is the bottom part. That's where, you know, that has to be where it bends. That just makes sense, okay? So I'm going to just put this dotted red line here so that you know that the red line is the axis of symmetry. And then let's fill in these blanks. The graph of the quadratic function is a parabola. And the vertex for this one is 1, 2, 3, 1, 2, 3, 4. So it's 3, negative 4. This parabola opens up, and therefore it has a minimum point. Okay, the minimum point is here. The minimum value of the function is negative 4. All right, and I'm just going to highlight that the minimum value of the function is the y value of the vertex. All right, because that's the smallest value that the function can get. The x-intercepts of the graph are 1 and 5. The y-intercept is 5. Okay, that's where it intersects the y-axis and where it intersects the x-axis. The equation of the axis of symmetry. Okay, it's an equation. This is what it pains me every time I have to mark this wrong, but it's an equation. An equation must have an equal sign in it. So we're looking for the equation for this dotted line, and that is x equals 3. Okay? If you just say 3, it's wrong, all right? X equals 3. That's the important information. And notice that that is always going to be the x value of the vertex. Okay? The domain of the function is going to be xer. X is an element of the real numbers because x can go as far to the left and as far to the right as exists. And the range is going to be, do the curly brackets, the range is y such that y is greater than or equal to negative 4, because it can be negative 4, and it can be negative 3, and it can be negative 2, and it can be 575, but it cannot be negative 5, right? The y value cannot be negative 5, and then a comma, and yer. Okay, so this tells us that the range is any real number where y is greater than or equal to negative 4. All right. Part E, how can the equation of the axis of symmetry be determined from the x-intercepts of the graph? It's halfway between them. Okay, so that means it's the mean of those two values. So in this example, it's 1 plus 5 divided by 2, and that gives us x equals negative, or sorry, not negative 3, x equals 3. X equals 3, okay? This is the equation of the axis of symmetry, all right? And that will always be true because the graph is always symmetrical. The only time it would not work is if you don't have any x-intercepts, but I'm not gonna give you those in this lesson, okay? All right, next page. We are gonna pop over to Desmos. Desmos is a fantastic piece of software. It's free, it's online, it's available for your iPad and your Android phone. I'm pretty sure it's available for the iPhone as well. And what it does is you put an equation in and it graphs it for you. It's just beautiful. So I'm just going to type in this equation that I've been asked to graph, which is y equals x. And then to get the squared, what I'm going to do, I'll write this down over here. I'm going to go, oh, it tells you right here. I have to put the hat, it's the hat button or the carré. So it's x, which is shift 6 squared minus 6x plus 5. Okay. Hey, look, it did the parabola for me. Isn't that beautiful? And we're going to confirm. So you can see, I can grab it and move it around. I can use my scroll wheel to zoom in or zoom out. And I'm just going, and if I click on the line, if I click on that red line, it highlights some points of interest for me. It highlights the y-intercept, which is 0, 5, the x-intercepts, and the vertex. You see there's those little gray dots there, okay? So it's so helpful. Please use it. It makes life easier for you. Okay, well, I'm just going to leave that there for a second. Then if I just click down here, it gives me another place I can put an equation in. I'm going to put in the example 3 one here. Y equals 2x squared minus 13x plus 15. Okay, and you'll see that it's done it as a different color so that you can distinguish between them. And if you click on the color part here, it makes it disappear. And if I click and hold, it gives me some other color options, so I can make it purple if I want to. Okay. Now I'm gonna get rid of that first one. Oh, well, I was gonna show you that it actually highlighted where the two intersected, but it's gone now, so I'm not gonna worry about it. All right, let's fill in the graphs. Let's fill in the blanks for this equation now. So the graph of the quadratic function is a parabola. The vertex is, so I'm going to click on the graph so that it gives me this, and the vertex is 3.25, comma, negative 6.125. Or if I wanted to put that as fractions, it's 3 1/4, negative 6 1/8. Just want to fix this. This is really messy and hard to read. Negative 6.125. All right, this parabola opens up and therefore has a minimum point. The minimum value of this function is the y value, so it's of the vertex, so it's negative 6.125. The x-intercepts are 1.5 and 5. And the y-intercept is way up here somewhere. That looks like 15, but I'm just going to confirm. Yep, it's 15. The equation of the axis of symmetry. So there's two ways I can do this. I can take 1.5 plus 5 divided by 2 gives me 3.25. Or it's the x value of my vertex, but it needs to be an equation. So it's x equals 3.25. All right. The domain of the function, the domain is all the x values, so x can be any real number. And the range is y such that y is greater than or equal to negative 6.125, and y is a real number. All right, you just have to memorize that that's what you're going to write for those things. Okay? All right. Example 4, line x equals 2 is an axis of symmetry of the graph y equals 4x squared minus 16x minus 9 without using technology. That means you can't graph it. You can use a calculator to do calculations if you need to, but that means don't use any graphing assistance, okay? Algebraically determine the coordinates of the vertex of the graph. All right, so what we know is we're looking for the vertex of the graph. So the vertex is a point, which means it's some x value and some y value. And we know that the x value is 2 because we know that the vertex is the x value of the line of symmetry goes through the axis of symmetry goes through the vertex. So the x value of the vertex has to be 2. Sorry, that came out kind of garbled. All right, and then here's an important thing about equations that somehow students get through school sometimes without understanding. What this equation does, what this curve over here does, is any value that I give for x and plug into the equation up here is going to give me a y value, and where I put those 2 points, where I plot the x and the y value, it's going to be on this line. And in fact, this line is made up of a billion little dots, where x is like 0.01 and 0.001 and 0.002 and 0.003 and 0.004. And what is the y value that gets spat out when you do that calculation? Okay, so coming back to this example 4, what I need to do is plug my value of x equals 2 into this equation. Okay, so my equation is y equals 4 times 2 squared minus 16 times 2 minus 9. And I just want to highlight those 2's so you get that that's why I put the 2's in there, okay? And then I get y equals 4 times 4 is 16 minus 32 minus 9 equals negative 25. So this means that when x is 2, y is negative 25. So my vertex is 2, negative 25. All right? All right. Let's do some things in Desmos. Okay, for this part, I'm just going to get you started on this, and then I want you to play around with it on your own, and then come back and I'll show you I'll write down what it is you should have gotten from this, but I want to show you something else that Desmos does that's really neat. So when the equation is y equals ax squared, that means I can put any value in for a, and I want to see what happens. So if I go y equals a x, see it says add a slider for a, and I'm going to say yes. So I just click on that, and then I do need to go back up here and finish my equation. So I've got my value, or my equation of y equals ax squared, and that's shown in green. And then I can take this button here and I can slide, and it's changing my values of a, okay? So this is the graph when a equals 2.6, so it's y equals 2.6 x squared, and this is y equals 3.1 x squared. And then I can go down, and what happens, okay? So you can play with that, and then you'll do this. So what did we notice? Coming back over here, in this example, b equals 0 and c equals 0. They've disappeared from the equation. They're just not there anymore. And what happens when a is changed and both positive and negative? So hopefully you see that if a is greater than 0, so let's go back to a equals 0. If a equals 0, it's just a straight line, but we were told that a is not allowed to be 0, right? That was part of the definition. So if a is greater than 0, a is greater than 0, it opens up. And if a is less than 0, it opens down. And um, a bigger, I'm just going to quickly, don't stress about this, but this is a concept of absolute value, which they used to teach in elementary school, but I don't think they do anymore. And absolute value just means how far is the number from zero. So what you really do is you just make the number positive. So the absolute value of -2 is 2, and the absolute value of -17 is 17, and the absolute value of 17 is also 17, because they're both the same distance from 0 on your number line. So the bigger the absolute value of A is, it stretches up like a vase, and a smaller absolute value of A flattens it more like a bowl. So let's just go back over to the graph. So you see as A is getting bigger, it's becoming, it's becoming taller and taller and taller and taller. And as A gets closer to 0, it gets more bowl-like until it gets negative, and then it goes the other way. All right? Okay, I'm going to get you to pause the video, and I want you to play around with this next part, okay? Welcome back. It says state the values of A and C, and that's in this equation up here. So A equals 1, because the A goes in is the coefficient of the x squared term, and it has to be 1. It can't be 0, or it's no longer a quadratic. And C equals 0, so it's just gone. It's like we have plus 0 at the end here. It doesn't do anything. And what we see over, if we look at Desmos, is that the the x-intercepts of the equation are 0 and -b. So if b is 3 in this one, and our x-intercept is 3, and if we make b is positive 3, the x-intercept is -3. If we make b 5, the x-intercept is -5. So the parabola moves so one y-intercept equals 0, and the other is -b. Now it's really important, this only works when c equals 0. Okay, which makes this not particularly useful. But if I come up here and I add, I go like +4, so I'll make my c 4. It's moved everything, so it doesn't work anymore. But it does still move it up and left and right. Okay, it's just got a different central point there. Okay, so pause the video, go and do investigation 3, and then come back. Okay, this time our A is still equal to 1. A is still equal to 1. And B equals 0 because the B term has disappeared. And what's happening to the graph as we change C is that it is moving up and down. All right. And specifically, the y-intercept is C. So here C is 3 and our y-intercept is 3. If we move this up to 6.8 or 7, the y-intercept is 7. Okay, so the y-intercept equals C. And that's actually always true. That one doesn't depend on what B is. So if we add a value for B, if I add in plus 3x, so my B is 3, my y-intercept is still the C value. Okay? All right, moving on. we're going to summarize this here because this is what you'll be answering these questions again and again and again and again. So let's make sure you know what answers we're looking for. So this is a summary of the characteristics of the graph in general of y equals ax squared plus bx plus c. So the shape of the graph is a parabola. The graph is symmetrical about a vertical line called the axis of symmetry. If a is greater than 0, the parabola opens up and the vertex is the minimum point. Now, just one thing to help you remember that. The basic equation of a parabola is y equals x squared. And if you were doing the pre-cal stream, there's all kinds of things you do with this equation, and you can tell from the numbers exactly where things are. And we don't get into that sort of detail here. But everything starts with y equals x squared. So if you can put this parabola shape in your head as y equals x squared, then you know that a equals 1 here, so it's greater than 0, it opens up, and this is its shape. That's just how I remember it, okay? All right, back over here. The y-coordinate of the vertex is the minimum value of the function. If a is less than 0, the parabola opens down, and the vertex is the maximum point. The y-coordinate of the y-coordinate of the vertex is the maximum value of the function. The domain of the graph is XER, so all real numbers. If C is greater than 0, the graph has a positive y-intercept, and that y-intercept is equal to C. And if C is less than 0, the graph has a negative y-intercept, which is equal to C. All right? Okay, go and do assignment 1. Make sure you do it all, okay? And feel free to use Desmos to help you out for questions that say you can use technology, and make sure you check your answers, okay? This is really a lot about vocabulary at this point, okay? All right, bye.